Section 11.4b is about right triangles and using the Pythagorean theorem to find right triangles. We'll start with some definition. Whole numbers that satisfy the Pythagorean theorem are called Pythagorean triples. A corollary is a statement that can be, there should be a B here, that can be easily proven using a theorem. And so you see this corollary for the Pythagorean theorem, and it's fairly simple. It just says that if the Pythagorean theorem works for three numbers, then you have a right triangle. But if the Pythagorean theorem does not work, if you plug three numbers in and they don't work, then you know for sure that you do not have a right triangle. So we're going to just try that with a couple of examples. We're going to take three sides, three values, plug them into our Pythagorean theorem, and we're trying to determine if these three sides of a triangle would make the triangle a right triangle. So we'll start with the theorem. The trick is which one of these sides is the hypotenuse, is the longest side. So you just see which number is the biggest, and that goes in for the C. The other two don't matter. I can put the 3 in for the A and the 4 in for the B, or I could switch that. It would not matter. So we're asked to see if 25 equals 9 plus 16. Well, 9 plus 16 is 25, so that's true. So we can say that a triangle with these three sides is a right triangle. How about this one over here? It's easy to see which one is the C. The 4 goes in there, and then these don't matter. You can put them in either order. So 4 squared is 16, 2 squared is 4, and 3 squared is 9. Is 9 plus 4 equal 16? No. So we can say that this is not a right triangle. Now we go down here to this one. We have three numbers. Which one of those is the hypotenuse? Now it's fairly easy to know that the square root of 5 is smaller than 13. So this one shouldn't be that big of a deal. Plug 13 in for C, square root of 5 squared for the A, and then 12 squared for the B. Well, 13 squared is 169. Root 5 squared. Square roots and squares cancel, so this just becomes a 5. And then 12 is 144. Is 144 plus 5 equal to 169? No. So these three sides would not form a right triangle. Now this one's a little interesting because it's hard for me to know what the square root of 119 is. If you have a calculator, you can plug it in and you're going to get a number like 10.9, and so you know that 12 is the hypotenuse. But if you have some square roots and you don't know what they equal, you should figure out what they equal. One thing you can do is you can figure out what the smallest perfect square is to 119, and so you might remember that the square root of 100 equals 10, and that's smaller than 119, and the square root of 121 equals 11, and that's bigger than 119. So you know that the square root of 119 is between 10 and 11, and therefore you would know that the 12 is the hypotenuse. So we'll plug that one in for the C, 5 for the A, and the root 119 for the B. 12 squared, 144. 5 squared is 25, and this is 119. So does 144 equal 144? Yes, it does. So we would say yes, these three sides form a right triangle.